Okay, guys, so let's just continue. Right. So uh where did we even stop stuff? I think we're okay, we're trying to call the request once again here after we had already called it within the space of an hour. So it's through an error and say that we have to wait before requesting again, right? And that was the instruction that we gave to our smart contract to execute. So basically, our smart contract is actually doing what we said it should do, right? So, I mean, if you could remember that one of the characteristics of a smart contract is that it is immutable, one, and then um, it is what's it called? I mean, the blockchain is immutable, and then the smart contracts provide a trustless environment. So what that means is that I do not have to trust this smart contract to use it because I expect that. I mean, as far as I enter an input, it literally does what it ought to do, right? So this abstract, they need to trust, you know, to trust what's it called? To trust it, you get, because normally, how we traditionally smart contract is actually an agreement, right? It's a contract. So traditionally when we have contracts, right, between let's say humans, right? Maybe between me and another and person B, for us to have a contract, like, okay, if I do this, then you should do this, right? I would need to trust that person to get, involved in the contract. But in contrast, when I'm interacting with a smart contract, I do not need to trust the smart contract I'm interacting with because all the functions that all the things supposed to do in the functions is will do it as far as I call that function. So that's what we're seeing here, right? So when I call this request function, rather than it's sending me or not sending me 0.01, right? So if I did not send, if I did not send Ethereum, I mean, if for instance now, sorry guys. So if sorry, I lost my train of thought. Okay, so this contract now, like when I call this function, it's supposed to request fund and send me 0.01 ether, right? So if I don't need, I mean, this contract now, when I call it, I cannot say that it's sending me 0.05 because normally it's supposed to send me 0.01, you get, because that's what it's programmed to do. So I do not need to trust it, you get. So now let's just continue, right? So because this address now is the owner, because I'm gonna deploy it, right? So when I click on cooldown time, I mean, when I click on set cooldown time, right? Let me pass one, maybe, or two, for instance, right? When I click on set cooldown time, this will set the time to wait to 2 hours. Let me see what will happen. So you can see that it actually goes through, right? Because this is a function that was called. So it set the time to wait to 2 hours rather than 1 hour. When I click on cooldown time now, you see that it's two. You get. So what's the last function again? Withdrawal amount. So now that withdrawal amount is equals to 0.01, we want to let's just try and set it to 1 ether so that when we request funds, it's going to give us 1 ether. So click on it, right? And it has gone through. So when we click on where's that thing again? Withdrawal amount, we will see that it's now one rather than 0.01, right? So I mean, so that's basically like what we have done in this smart contract. So it's sort of just model out doing all the things that it's expected to do. So let's try and deploy it on a real blockchain that we can interact with. So when we click on this, we're going to click on you're going to come here. You can just click on here directly, but one of the ways I used to use Wallet Connect. So when I click on Wallet Connect, I'll wait a while, just a bit. So we see that something popped up. You see Connect Wallet. So when I click on Connect Wallet, it's going to ask for the wallet to connect. I'll click on MetaMask, and then automatically, because I already have my MetaMask here, so it's automatically connects with my MetaMask, right? So we can see that the accounts here now, rather than we using the account that Remis gives us. Now we now have our own smart contract. I mean, we now have our own wallet address that we can control and interact with on MetaMask, right? So now, um, let's deploy, right? Let's deploy. I mean, let's compile first, rather, because now we're dependent on a new network, right? So let's click on our faucet so, and then compile it again so that we can deploy. So now it has compiled successfully. We'll now come here and click on deploy. Yeah, so let's deploy our contract on Sepolia network. So we'll click on deploy here. It's creating. So yeah, so now it requires us to sign transactions basically because that's one of the roles that wallets play, right? So because it's a wallet I control, so what's it saying? It's saying that, there's a request from Remix, which is this, to deploy these contracts. And then on Sepolia Ethereum, you get, and then we need to pay network fee or gas fee that we've gone through in our previous class, right? So we just click on confirm, right? So when we confirm it, we see that it's creating here and it's pending. So let's see. It means the transaction is processing on the blockchain. So yeah, so you see that it took a while, unlike that remix one that was very fast. So now because this is actually a real blockchain, it's going to have to wait just some certain seconds to process. And now we can see the option of viewing it on Etherscan. So we're going to click on that soon. But let's see what happened here. Um, so yeah, it shows that there was a call to deploy this contract from this wallet address, which is this my address here on this MetaMask wallet. You can see that it's the same thing. Where is that thing again? OXB998. You can see that it's the same thing, right? So you can see that here now, when we check this, we're seeing the smart contract address that we have deployed, which is this, right? Sepolia, let's click on it and to drop down. You can see that Sepolia faucet OXDEF, right? Sorry, OXOEF and 3279. So we can see that, what's it called? That this is our smart contract address, right? So let us try and view it on Etherscan. So Etherscan is like, it's going to refer us to Sepolia to see our transaction on the blockchain. So yeah, this is where, because everything on the blockchain is actually public, right? So everybody that have access to this Sepolia Etherscan, Sepolia blockchain can literally see our transaction. It gets, which also, you know, um, elevate the characteristics of the blockchain and smart contracts, the transparent nature of the blockchain, where anybody on the blockchain can see everything going on the blockchain, right? So we can see that this is saying that this is a Sepolia testnet transaction, right? Because we're deploying it on Sepolia Ethereum. And then we can see that, you can see the person that made this function call to deploy this contract, and this smart contract was created. So let's click on this smart contract that was created and see what it is. So when we click on this, we see that it's a contract, right? So it's a contract. It's like our own smart contract, right? So, and the creator is OX9BB, which is literally my address, right? So yeah. By the way, if you had noticed, my initial balance was 0.097. So I had to pay to sign this transaction, I had to pay gas fee, right? And I was dotted some certain amount of $3 worth of Sepolia Ethereum, which is like a test token. So that was why my balance reduced here. So as far as for any interaction I'm making on the blockchain, the initiator of that transaction will be the one to pay the gas fee, right? Because just like saying the messenger sender will be the one to pay the gas fee. So when you check the contract, you see that, hey, now we see that this is the bytecode. Now this is the code that the computer understands, right? This is like our smart contract. All this code we have written here, it has been converted to bytecode here that the computer understands, right? So we can deploy bytecode to be able to read, be able to convert it to a human readable, what's it called? A human readable, um, basically. a human readable code, right? But I'll have to verify it, and that will take another process. So let's just keep that. It's not really necessary for now, since we have right this in our code there. So now let's just try and perform the other actions that we've been performing. So when we now our by default our smart contract it has a balance of 0 bar, and now we can see that it's on Sepolia Ethereum, right? And it has a balance of 0 Ether here bar. So now let's try and deposit with 0 amount, which expect that it's going to revert. So let's try and deposit. So what's it saying? Okay, it's saying that it may fail. I mean, because of the gas estimation, right? So we have to provide the where is this sense of okay, yeah. So the estimated gas. So let me try and can I okay customize. So let me try and increase it so that I can have this is actually in way you get so it's in way, right? So let me try and just set it that it should be able to charge as much gas as possible so that we not have this problem again. So let's try and continue. Let me try and deposit now. So what happened was that the gas amount I set was not enough to cover the transaction. That's why it did not go through. So now that I've increased the gas amount, right? Um, is actually pending. So the transaction is pending. So we have to wait because this is now a real what's it called? A real blockchain that we can access in the real world. So so it's pending. So we would wait a while and just wait for it and see. So you can see that it's a bit more slower than the time we're using the Remix VM again because that was like a fake or simulated blockchain. Now this is a real blockchain, just that it's a blockchain to test. It simulates a main blockchain called Ethereum, right? So the transaction is pending, and we have to painfully wait. Although it doesn't used to be like this. I mean, sometimes it may happen probably due to network congestion, like if there's too much pause or if there's too much things going on the blockchain, it's going to be a bit slow to confirm our transactions, right? So one of the ways you can use to speed up transaction is providing more gas fee, right? So let's see. Let's call it again deposits. So uh, okay, so now we're now having the same issue we had earlier, right? Just that now we do not have control over this. You get because this is like a real blockchain, so we just have to wait, right? So let's just move on. But then what was supposed to do is to increase the deposit balance. I mean deposit some Ethereum to this smart contract on mainnet, I mean on Sepolia, right? And the balance of our contract should increase. And then we would have called the request funds function to take out Ethereum from the smart contracts, right? And then we can also set cooldown time. So basically what we have done on the remix version machine, that's what we're supposed to do. We're going to do it again, but that's what we want to do again. But now it's taking time, so we just have to maybe redeploy or we move on to the next one. So let me try one last time and see. Okay, so let's just move on, right? Since we already simulated it on, the remix version machine. So we're literally just going through it again, but now on the Sepolia blockchain, but it's kind of not going through at the moment. So guys, that was to simulate how the transaction or how the smart contract would have worked on a live blockchain, on the Sepolia blockchain that we could have access to. Yeah. But now we can see that, at least we have deployed our contracts, and this contract now is available on mainnet, right? So literally everybody that just come across this smart contract can interact with our contracts and get, what's it called, and get Sepolia Ethereum from the contract, right? And call all these functions, the ones that are callable by normal users. So guys, this, sort of just brings us to the end of this whole session, right? And like it's been nice to actually talk about Web3 as a whole, and from the base of blockchain to how to build smart contract and how to deploy smart contract, how to also test smart contracts, right? And we had also gone through, cryptocurrencies, we've gone through native tokens, we've gone through transactional gas, we've gone through wallet address, where we have a wallet address and we also have a contract address, right? So we also gone through layer one and layer two, and we had gone through smart contracts, which we just finished writing, right? So like so I was trying to explain something, right? So I mean, there are career paths in Web3 basically, right? And I'm going to focus on what I am actually doing, which is Web3 security. So what does that mean? So what Web3 security researchers do is one of the roles of Web3 security researcher is to audit smart contracts and try and spot vulnerabilities in smart contracts, right? And then like this smart contract now, a smart contract security researcher or a smart contract auditor, the role is going to just what's the word, audit this smart contract and check if it's supposed to do what it's doing, or check if there are some things that could be exploited, you get, that could literally make the smart contract lose money, or maybe the users lose money, or maybe things that would affect the protocol, affect the users that are using this particular smart contract, right? So basically, it's just to spot vulnerabilities, mitigate the vulnerabilities that could affect projects and users, right? So for you to do this, you guys have an understanding of Solidity, which is a programming language. And in our last class, I uh, actually referred to Siphon Updraft. Let me see, Siphon Updraft. So we just come here on Google and type Siphon Updraft, and then we'll click on the first link we see. Uh, okay, great. So we can see that this is a platform to learn, basically anything about the blockchain, and also for those that want to be a blockchain developer. This is a platform that teaches you how to code Solidity and how to understand the blockchain, right? So it's actually free, right? It's like Udemy, but it's free, but mainly for blockchain and smart contracts security. So when we explore our courses, we're going to see, this is actually where I learned, you know, and I'm even still learning, right? Because I mean, we learn every day. This is where I actually learned, um, you know, how the blockchain works, and learned how to become a security auditor, right? So although I was a backend developer, right, for about 1.5 years, and then I had to make the transition into Web3 security. So it was much more, seamless. But then, regardless of if you have a programming background or not, like coming to this platform and taking this course, this is what I'm going to advise first. Take the blockchain basis course, right? To learn about the basics of the blockchain, right? And then if you're interested in becoming a developer, I mean, literally anybody interested in how Web3 works should actually even take this blockchain basis course, because it explains a lot of things, like a lot of fundamental things about the blockchain and about Web3 as a whole, right? So if you want to become a developer, a Solidity developer, you take this course, So it's a 101, right? And then you take this Foundry 101. So this is like a way to test your AT code, right? And then you can see that the difficulty level is actually written there, beginner, beginner. This is intermediate, right? Then after this is the advanced Foundry course, which is literally building on top of this Foundry 101 course here. So this is a bit more advanced, but then it should not scare you if you want to become a smart contract security auditor or even a solution developer. You should actually take this, right? And then if you want to become a smart contract security auditor, security researcher, you should